Good evening. We are the Professor Armando and the Professor Alan, and we're going to give a short class about the topics of work, energy, and power. First of all, what is work? Work is defined in physics as a measure of energy that is as a transfer of energy that occurs when an object is moved over a distance by an external force, at least part of which is applied in the direction of the displacement. The formula is work is equal to force times S, that is the displacement, times the cosine of the angle. The letter we use to represent work is W. W is work, and the unit we use to represent work is joules.
Well, I'm going to talk about angles in work. Well, with the angle, we can know if the work is positive, negative, or null. For example, when the angle is equal to 90 degrees, the work is null. When the angle is higher than 90 degrees, the work is negative. And when the angle is less than 90 degrees, the work is positive. Well, first, I'm going to explain this work exercise. An object is displaced along a horizontal surface by a force of 15 newtons by a distance of 10 meters. The kinetic friction force is 7.5 newtons. What is the work of the horizontal force? First, we're going to draw the exercise. First is the box with that is pushing with a force of 50 newtons with a distance of 10 meters. And the kinetic friction is 7.5 newtons. Well, according with the formula, the thing that we could do is 15 less 7.5 per 10 meters. And that's equal to 75.
Now we're going to talk about energy. The energy is the capacity that an object has to generate movement and to make a mechanical movement. The energy is divided in potential and kinetic energy. The energy is also expressed in joules with a J. The kinetic energy refers to the energy of an object in motion, and the potential energy refers to the energy it possesses in relation with the position of the object. Right here we have the formulas. The formula for the kinetic energy is 1/2 times the mass times the velocity elevated to the square. And here with the potential energy, it's only the mass times the height and times the gravity. Well, right here we have an exercise of potential energy. And first we're going to draw the problem. The mass, it is 5.49 kilograms. And the box is over an 80 centimeter table, but we need to transform it into meters, so it's 0.8 meters. And well, according to the formula, and the formula is the mass times the height and times the gravity. Now we substitute values. That is 5.49 times 0.8 and times 9.8, and the result is equal to 43.04 joules. Okay, now we have a problem of conservation of energy. First, we're going to draw the problem. A projectile of 0.12 kilograms is thrown vertically downwards with a velocity, oh sorry, mm, with a velocity of 9.86 meters per second. And the projectile is thrown from a height of 12 meters. And well, according to the formula, we only need to multiply 1/2 times the mass, that is 0.12, you got the dot, times the velocity, that is 9.86, and this we have to elevate it to the square, and then we add again the mass. We already know it, that is 0.12 times the gravity, that is 9.8, and well, I'm going to draw it right here, times again the height, that is 12. And well, all of these results in 19.94 joules. And concluding the energy, the law of conservation of energy, it's like a mixture between the potential energy and the kinetic energy. And we mix these two energies and we get the conservation of energy.
Now I'm going to explain the power. Well, the power refers to the quickness for making a mechanical job. The unit used is the watt.